In this next series of videos, we want to look at factoring binomials. We always look to see if we can factor out a common factor first. That's what we always try to do, no matter what kind of polynomial we have. And if we look at those two factors, those two terms, we see that they share no common factor other than 1. But I always want to check for that. Now, there's a special pattern. Other than factoring out a common factor from each term, if we have a binomial, the binomial has to fit a special pattern for factoring. And that special pattern for factoring is called the difference of squares. And in order to test whether or not I have the difference of squares, the first thing I have to ask myself is, do I have a difference? And remember, difference is the answer to a subtraction. So yes, I have a difference. So perhaps this is the binomial that's the difference of squares. The way I can figure that out is to fill out what I call the squares skeleton. I'm going to ask myself, first of all, what could I square that would make 4x squared? What could I multiply times itself? That's what squaring is. What could I square that would make 4x squared? And that would be 2x, wouldn't it? 2x squared, 2x times 2x is 4x squared. Then, what could I square that makes 25? Well, that would be 5. So this binomial is the difference of two squares. And by filling out my squares skeleton, I've been able to see that. Well, the difference of two squares always factors into two binomials. One with addition, the other with subtraction. Into the first position of the binomials, I put the term that is in the first position of my squares skeleton. So here I will put 2x for both of those first positions of the binomials. The term that I put into the second position of the binomials is the term that is in the second position of my squares skeleton. So in this case, that will be 5. And this is the factorization of that binomial. Remember this special pattern when we multiplied with FOIL? Remember how when the terms were the same and one was plus and one was minus, that the O and the I always canceled out to 0, just leaving us the square of this minus the square of this? You know, the square of 2x minus the square of 5. It always just left us the F and the L parts of FOIL. The O and the I canceled out. So here we're just reversing that. We're taking that binomial, finding the pair of binomials that when we took their product with FOIL, it produced that particular special pattern.